Hey, hi, hello guys, welcome back to Code with Nani channel. So today we're gonna discuss Leetcode problem of the day, zero array transformation 2. So basically you are given array nums of length n and a 2D integer queries, where queries of I, in which you will be having a three values, L of I, R of I, and the value. And so in each query of I, we need to decrement the value at each index in the ranging from L to R. So what is basically saying is, for in each query we'll be having left, right, and value. So we need to decrement the nums by the value from index left to the right. Okay, by at most value of 5, and the amount by which each value is decremented can be chosen independently for each index. Okay, a zero array is an array with all its elements equal to 0. So we yeah, if it is possible to convert into a zero array, then we just need to return the total number of queries required to make it a zero array. So return the minimum possible non-negative value of k, such that after processing the first queries in sequence, nums nums become a zero array. If no such k exists, return k, return -1. So what they were saying is, so you will be given a queries of size some k. So size, let's just say length or something like that. So in each query you will be given left, right, and value. So what we need to do is individually perform that query and decrement the nums by the value in the queries of I, from the left index to the right index. So what they were saying, basically saying is, so you are given nums, right, which is 2, 0, and 2, and we are given the queries, which is a 2D array. Okay, so 0 to 1, 0 to 1, 1, 1, 3. Okay, so these are the three queries. So in each query, the first value is left index, the second value is right index, this is the value. So what we need to do is, on each query, so on the first query, what we need to do is, we need to make L is equal to 0, R is equal to 0, and val equal to 2, right? Sorry, 1. What's the meaning of it? Which means we need to decrease the nums array by the value 1 from the index left to right. Okay, from the index left to right. Okay, so so 0 to the second index. So this is the 0th index, this is the 1st index, this is the second index. From 0th index to the second index, we need to decrement the value by 1. So which is 2, um 0, sorry, 1, 0, 1, right? So as they given, the amount in which value is decremented can be chosen independently for each index. So what they are basically saying is, here it is already a 0 value 0, so no operation is required, right? So you can choose value as 0 for this specific index, apart from the value 1. What they are saying is, at most you can choose value of I, like at the most you can choose 1, but you can choose 0 as well, right? So in this index we choose 0 because as it is already a 0, no need of any value to decrement. And in the second index we choose 1 and we decrement it. In the next query as well, what we are trying to do is, we'll just reduce 1 from 0 to second index. Now the array becomes 0, 0, 0. So it becomes a zero transformation array. So how many queries required for this array, nums array, to make a zero array transform? So basically 2. Even if we perform in the third query, where we can choose at most 3, which means you can take 0, you can take 1, you can take 2, you can take 3 as the val. You can perform by these values by decrementing 0, 1, 2, or 3. So if you perform 0, will be fine, as it is a zero transformation array. So you can achieve zero transformation by using all the queries, but here the optimal state is by doing only two queries we can able to achieve the zero transformation. So that's you need to return. So the k value is 2, which is two queries in a sequential manner is enough to achieve the zero transformation. So that's what we need to return. If there is no solution such exists, we can just return -1 as a solution. So how do you approach this solution? So how do you approach solution? As you can see, as the constraints of this solution is, we have a queries of size one size length 1 to n, where n tends to, we have a queries. Suppose, let's just break the code. Even if you don't want to get the exact k number of queries, even if you break it into a simple component, we need to check whether after applying all these queries, whether this array, whether these nums can be able to achieve that zero transform array or not. How do you achieve? So in a brute force approach, what you will do is, we'll just iterate through all the queries, I less than queries, I plus plus. In each iteration, we'll just iterate from this left to right, and we'll make a changes, right? For that case as well, we are performing O of n square solution, which is that queries dot size square. Let's just take it as a L. Let's just take query size as L. So we are taking L square solution. So according to our constraints, L is 10 power 5. So if you want to, instead of optimizing to the queries of size k, even to just to check how many, even after applying all the queries, is it can be achievable to the zero transformation or array, it's still a n square solution, L square solution in a brute force approach, which cannot be used here because it gives you a TL as constraints here is 10 power 5. So 10 power 5 into 10 power 5, which is 10 power 10. So 10 power 8 is 1 second. So which definitely gives you TL. So this solution doesn't work. Okay. So what I'm planning to do is, we'll just break a solution. First, we'll break the solution. First, we'll see how to achieve it in a of n solution. So this type of algorithms are called range queries. So in a certain range, we'll apply these queries and get the answer. So these type of problems are called range queries. So how do you find, if we apply all the queries, whether we can able to achieve it in whether we can achieve that of n, which is zero array achievable or not? How do we say? As we cannot do it in a brute force manner, which is gives you a TLA. So for that, we use a prefix array. Let's just take, so what we can do is, let's just take this example, 202 202. This is the nums of array, and the queries are 0 to 1, 0 to 1, and 113. So these type of range queries, how do we apply? So for that, we create a prefix of array which is of the same length as n. Okay, initially 0 1 2. Initially we'll initialize it with 0. Okay, so when you are iterating towards these queries, so when you are iterating towards query, what we can do is, so as here when you see, from left equal to 0, right is equal to 2. So from 0 to 2, the value will be decremented by 1. So in the increment case or decrement case, just put the value as a positive only. If you need decrement case, just subtract it, or if you need an increment case, just put the same value. So from 0 to 2, we require 1, right? So in place of left, in the prefix of left, we'll add value, which is 1. Cool. We'll add 1 to it. And prefix of r plus 1 equal to minus equal to value, because what we are trying to do is from L to R it will be a value. So what in the next so what I'm trying to do is, right now I'll put left as the plus value. Okay, now it is 1, right? And in the right plus 1, so as you here right is 2, 2 plus 1, which means third index will minus it with 12, so that from the third index value wouldn't be added. Okay, here we don't have a third index, we'll leave it as it is. And in the next iteration as well, we will increment the zeroth left index with 1, which is now this value becomes 2, and the 0. And the right index, what is right index? Right index is 2 plus 1, which is third index. We don't have any third index, we'll leave the right index, as it is. Now it is 0. And for L, we'll increment by 1, and R plus 1, which is here we'll right is equal to 1 plus 1, which is second index. In the second index, we'll subtract with value, which means minus 3. Okay, so in the end, we got this array as here plus 3, left plus 3, and right plus 1 minus equal to 12, which is in the current index it is 2, here 3, here minus 3. So if we get these values, what we need to do is we will prefix some, because as you can see, what we did was we make sure that left plus equal to 12, which means the left has been updated, and right plus 1 minus equal to 12. So we need to prefix some, right, from L to R, so that all the values in the particular indexes will be updated. What we did was, until now, the starting pointer we increased the value, and the ending next pointer we decrease the value, but we didn't update the middle values, right? If you prefix sum it with the left value, then all the values will be updated. So that's what we do. So we'll write a for loop int I equal to 0, I less than previous, I plus plus. Just don't think about the syntax, I'm just writing it as a pseudo code, so you'll get clear about it. This is the prefix sum. Now let's I equal to 1 2. Now prefix of I equal to I plus equal to prefix of I minus 1. So which means what we're trying to do now, this 2 3 minus 3 will become, so as the first index as such, because the left wouldn't be changed, only the middle part need to be. So 2 plus 3. Why 2 plus 3? Because in the first query, in the first two queries, that index is ranging from 0 to 2, so that has an impact on the first index. And in the last query also we have a impact on this index as well. So 2 plus 3 5, and 5 minus 3 2, because this will prefix sum is, because in the last index we have, in the first index we have a, in the first index, in the first two prefixes we have an increment of 2, and in the last query we have a decrement of 3, just accumulating it, right? So that will be the prefix. So that's how we now that's how we solve these range queries. Now we need to check whether it can be achievable. Now this is the prefix sum, right? So what are the these things? Like after applying all the queries, the first index can be decremented by two, at most two values. These can be at most two values. These can be reduced by three values, right? Now check the nums of array. 2 0 2, right? So at most, how much we can decrease? 2. So if you decrease by 2, yes, it can be down to 0. As it is already down to 0, we don't care about it. And how many values at the most it can be reduced? It can be reduced by 2. So it is also a 0. So we can able to achieve all three values as 0, which means we can able to achieve if you zero transform array by applying all the queries. So that's itself a sub problem, which is whether we can able to achieve all the queries, all the by applying all the queries, whether we can able to reach a zero transformation array or not. So from this we need to reduce. Why we need to reduce? So now we find a solution. Now we find a solution that it takes O of n time to check whether if we apply all the possible queries such that it can be achievable or not. Now Now we need to check how many how many exact queries number of k in which we can able to achieve zero transformation array. So for that, what you can do is, for int I is equal to 0, I less than query start size. So on each in each index of I, which means like if index is 3, we'll check for whether 3 queries can be sufficient to achieve a zero transformation array or not, right? Check, we'll check. So for each index we are checking this, whether whether it will be doable or not. So for each index I, it takes O of n time, which means O of n square. Still, even if you know how to use the range query, still the solution going in an n square way, which is even that n is also 10 power 5. If on n square, which is a 10 more than 10 power 10, which is more than 1 second, which gives you tally. So you need to find a solution to reduce. Instead of going to entire queries, we need to find the exact k number of queries. So what you can do is, so here you can use a binary search. Binary search, the second subcomponent of this solution is a binary search. So if you use a binary search, it takes you log n time. So each query takes log n time, and you have n queries, right? N log n, probably mostly n log n time. So if take 10 power 5 into log of 10 power 5, which is around 5, because as it is something around it will be a 6 into 10 power 6 or something, which is less than 10 power 8, which it doesn't give you a TLA. So how do you approach, how do you use this binary search? So my intuition is, suppose you have a queries of size 1 2 3 4 5 6 and so on. Suppose we have n queries. Okay, right, cool. Suppose what my and in the end, what we need to do is, we need to make this whole transformation array to a zero array or not. Suppose if we used first three queries and we can able to achieve zero transformation, okay, then even if you use the fourth query, if you use fourth query, then it will be down to -1 or -2 -3 something. If you achieve zero, that will be sufficient, right? So if you able to achieve zero transformation by this third array, by these third queries, means you don't need to check these things, because definitely even if you apply those transformation, definitely you will be getting zero, because by using a 3 we are able to get zero. Means if you use the fourth query, which means the next query, still the value gets reduced, so still you definitely you can achieve the zero, right? So and and so that is the one case. So another case is suppose you applied 5 transformations. Okay, if you applied 5 transformations, okay, now you choose a 5 as your k. and if you applied five queries, even after applying five queries, you aren't able to achieve this means if you apply less than five queries, which means like less queries, which means if you apply less decrement value, definitely you won't get it. Even after applying five queries, you are not able to get it. Means if you apply the less than five queries, which means like the decrement value still be lesser than the fifth five queries, definitely you couldn't be able to achieve it. So that's the real intuition behind it. So so what I am trying to say is, so you will check for a mid element whether it is possible to uh, so what my intuition is, you will check for a you will check for the mid element. If it returns true, which means it can be doable, so you don't have to check the right part, because if this element can be achievable, right side part definitely can be achievable. So in that case, what you do is just put the answer vector answer equal to mid, and you will decrease the right as mid minus 1. We will check for the left part whether there is an optimal k as well. Okay. Else, which means even after applying these mid queries, still you aren't able to get it. Then what we will do, you shouldn't go to the left way, because in the left part you definitely won't get it. So we'll check for the right part. So that's the binary search we use. Okay, just tricky approach. So for a binary search, it takes log n time, and for each mid value will take n time. So total time complexity be of n log n. And what is the space complexity? We are using a prefix array to solve the range query. So for that it takes of n time. So the time complexity is of n log n, and space complexity is of n. Yesterday they give you very easy problem, and now this is a very tricky problem, involves two concepts. One is range queries, another is binary search. So I'll just walk you through the code. You'll get clarity about it. So so you are given nums array and queries. So first I'll just explain you this. So if there is no solution exists, just return -1, right? So what I'm trying to do is I'm putting L as 0, left as 0. What is the maximum value of R? There might be a case like after applying all the queries you can able to achieve, so that will be the rightmost part, right? So R will be the queries dot size, and answer is -1. So if there is no solution exists, we'll just directly return -1. Okay, while right left less than or equal to R, until this left less than or equal to R, we'll get a mid element which is in between the L and R. Suppose if that mid can be doable to achieve a zero array, then what we need to do? We shouldn't check right. We can directly check the left part of the mid. Why? Because if this element can achieve, then rightmost element, every element can be able to achieve that zero transformation. But what we need the minimum k value, right? So for that sake, we'll check left part of the mid. So that's why r equal to mid -1, and we are storing that value in a mid. If that element cannot be done, which means that leftmost part cannot be done, because even after applying a max queries of mid we cannot able to do, then mid -1 queries definitely cannot able to do. So that's why we'll check for the right part, at least mid +1. So in the end, whatever we will return the answer. So I'm just constructing a bool check lambda function to check whether this mid is possible or not. So for that I'm maintaining a lambda function. You can write a different function as well. So but I'm more into this lambda function, because if you write a different function, you need to pass the parameters, like you need to pass the nums as well, queries as well. Suppose if you write a lambda function, it still be in the inside of the function scope, so shouldn't able, like, no need of this nums and queries as a param passing into this lambda function. That's why I generally prefer the lambda function in order to get rid of the huge parameters passing into a specific function. So what I'm doing is I'm just writing a lambda function which takes length means it is the mid value, like for that specific k value, whether it is doable or not. So I'm just so After this arrow which represents the return type of this function, we need to return a bool, which basically holds whether it is doable or not. So as I explained earlier, now we'll perform for that specific mid. We'll apply the range queries and we'll check whether it is doable or not. So for that, I'm just using a prefix array of initializing with 0. I is iterating from I0 to length, which is that specific mid value queries. So if the length is 5, we'll just check for that first 5 queries, 0 to less than plus. So queries of I of 0 holds the left part of the index, right holds the next index of the queries, and values will be queries of I of 2. What we need to do is we need to make sure that left plus equal to value, as I told you before in the examples cases and all. And we need to reduce the value of the right plus one index, right? But why am I applying this condition? If the right is the last index, then doing right plus index, which will be the outside of this prefix function. So to make sure that it just not out of the bound condition, I'm just using right plus 1. If it is less than n, then we'll update that value, prefix of right plus 1 minus equal to value, because we are incrementing the left side. Then right plus 1, the index should be eliminated from this range, right? Suppose you are increasing on the left part of this index, and after using this prefix array, we are just incrementing all the indexes from L to R. Then we need to neutralize that increased value, right? So for that case, we are just using prefix of right plus 1 minus value. So if you had any confusion, just reverse the video in which I explained using an example, so we'll get clear about that. And to hold all the values, like to make sure that impact holds on the all the values, not on the left and right part, we'll just increment from 1 to n, and we'll make a prefix sum with the previous value, so that the impact value will hold all the values, not only the first and last, even in the middle values as well. Now we will increment from 1 to 0 to n. In any case, in any case, nums of I minus the maximum decrement value, which is in the prefix of I, if it is still greater than 0, which means which means, suppose if it is less than 0, which means you can able to achieve 0, right? If you can able to achieve minus 1, which means if you take a less than one number, you can able to achieve 0, right? So that's what we're doing. Even after applying the max decrement value, if you can't able to achieve a less than 0 or equal to 0, then just return false. That's what I'm doing. Nums of I minus the max decrement value, if it is still greater than 0, directly return false, else return true. If it is false, then it will fail for a mid, and it will we'll check for the right side part of there, or else left side part of there. So that's my solution. Let's just run the code. Just submit the code. Voila, it's submitted. And that's it for today video, guys. So if you like my explanation, do subscribe to my channel, hit that bell icon so that you never miss any notification from my channel. And if you had any queries regarding my solution or regarding my explanation, do put it in a comment section. I will help you out, guys. And that's it for today video, guys. Thank you. Tata, bye bye. See you tomorrow with great content. Tata, bye bye.